Question number 1 says express the following numbers in the standard form. So before we start expressing each of these numbers into standard form, let's have a quick recap of what is a standard form. So a number is said to be in standard form if it is expressed as the product of a number which lies between 1 and 10 and the integral power of 10. So we will start with the first bit. We will first write it as a product of the given number and 10. So we take the power of 10 as 0 because anything raised to 0 is 1 and that does not change the value of the given number. Now our objective is to get this decimal point between 8 and 5 because then we will get a number which lies between 1 to 10 and we can write it as a product of that number and as an integral power of 10. So now let's see by how many places do we have to move this decimal point towards right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So it is to be moved towards the right direction by 12 places. So the same number has to be subtracted from the power of 10 because the decimal is moved towards right. So we write it as 10 raised to 0 minus 12. That gives us 8.5 times 10 raised to negative 12 as the standard form of the number given in the first bit. Now let's get on to the second bit. In this bit, we have to get the decimal point between 9 and 4. So we first times it with 10 raised to 0. Now let's count how many places it is to be moved. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we write it as 9.42 times 10 raised to 0 minus 12 because we moved the decimal towards right, so the power must get subtracted. That gives us 9.42 times 10 raised to negative 12 as the standard form of the number given in the second bit. Now for the third bit, we see there is no decimal given. So in such cases, we take the decimal after the last digit, that is here. Now our objective would be to get this decimal point between 6 and 0 and we times this number with 10 raised to 0. The catch here is that we have to move this decimal point towards left instead of right. So let's see by how many places should it be moved. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So when the decimal is moving towards left, the power must get added. The same number must get added. So we write it as 6.02 times 10 raised to 0 plus 15. So that gives us 6.02 times 10 raised to 15 as the standard form of the number given in the third bit. Now for the fourth bit again, the decimal is to be moved towards right so that it is between 8 and 3. We first write it as a product of the given number and 10 raised to 0. Now on counting we get that the decimal is to be moved 9 places towards the right direction. So we get it as 8.37 times 10 raised to 0 minus 9. So that gives us the answer as 8.37 times 10 raised to negative 9 as the standard form for the number which is given in the fourth bit. Fifth bit again we do not see a decimal, so the decimal is to be placed after the last digit that we see. And our objective is to get the decimal point between 3 and 1. We times it with 10 raised to 0. Let's count by how many places do we have to move it towards left. We have to move it towards left by 10 places. So we write it as 3.186 times 10 raised to 0 plus 10. So that gives us 3.186 times 10 raised to 10 as the standard form of the number given in the fifth bit. And this is how we solve this problem.
To know more about how QMath can help you become a master of math, explore QMath Leap, a live online classroom program taught by highly experienced and committed teachers.